Hello friends, in this video I'd like to solve the following problem from the Pan-African Mathematics Olympiad, year 2001, problem number 1. We wish to find all positive integers n such that n cubed plus 3 over n squared plus 7 is a positive integer. So my hints for this problem, first of all, try to write n cubed plus 3 as something times n squared plus 7 plus something else. So just do polynomial division, in other words. And also it may be obvious, but if a and b are positive integers, and if a divides b, then obviously a must be less than or equal b. So any divisor must be less than or equal the number being divided. So give this problem a try, and I will see you in a minute. Okay, so I hope that you've managed to solve it. As I suggested, let's first of all, let's notice that this number is positive integer if and only if, in fact, n squared plus 7 divides n cubed plus 3. And now I will do the following. I will take n cubed plus 3 and I will write it in this way. N cubed plus 7n squared plus 7n minus 7n plus 3. Okay, the result is the same, but now I can, from these first two terms, I can factor out n, and I have n squared plus 7 minus 7n minus 3. And now notice that this part is obviously divisible by n squared plus 7. So our division happens exactly when n squared plus 7 divides 7n minus 3. So now we wish to check, we want to see when this happens. And now, let's write it again. And first of all, let's notice that on the left-hand side, here we have a quadratic function, which happens to be usually, not always, much greater than any linear function. So the idea is that for sufficiently large n, this number will be greater than the number on the right-hand side, and divisibility will fail in these cases. And it's pretty easy to see. You can solve a quadratic inequality or something like that. It's pretty easy to see that notice the following, that n squared plus 7 is greater than 7n minus 3 for n greater than or equal 6. Pretty easy to verify that. So, and that implies that we have to check only n from 1 up to 5. Once again, why is that? Well, because when this number is greater than this number, our divisibility cannot be true. Cannot be true because we are dealing with positive integers. So now we must just check 5 values, and maybe I will do some kind of table. n squared plus 7, 7n minus 3, and let's put the values 1, 2, 3, 4, and 5. And after doing that, we will get the following. Here we have 8, 4, 16, 18, 23, 25, 11, 11, 32, 32, And we see that our divisibility holds only in two cases, namely when n equals 2 or when n equals 5. So n squared plus 7 divides 7n minus 3 if and only if n is 2 or 5. And that is exactly our answer. Our fraction is an integer if and only if n is either 2 or 5. And that closes our video. Thank you for watching, and I will see you next time.